Start.
Hello everyone, I'm Varsha, currently an intern at Emertxe Information Technology. We are in a group of three, I, Varsha, Tanmay and Sushma. We are doing this internship based on embedded systems. And during this internship, we have built a project based on MPLAB X IDE simulated on a software named PICSIMLab. So we worked on a project that is microwave oven stimulation. The learning outcomes are introductions to C, conditionals, loops and operators, arrays and pointers, functions and strings, memory and storage classification, introduction to embedded system and microcontroller. We have also learned how to use MPLAB X IDE, how to compile with XCA, how to stimulate on PICSIMLab. And we have also attended various quizzes and Disha workshops. Contents: Introduction of microwave oven, project requirements, microcontroller, PICSIMLab, CLCD, matrix keypad, interrupt service routine, timer, and we have at the last we'll do the project implementation. Embedded system. Embedded system is something which is a combination of hardware and software intended to do a specific task. The types of embedded system are standalone system, real-time system, network system, and mobile system. These are the real-time applications of embedded system. Standalone system, network system in this picture. Classification of memory. Memory is being classified as RAM, high speed, and ROM. Embedded system challenges are basically based on code optimization, testing, and debugging. Microcontroller. A microcontroller is designed to do a specific task, and whereas a microprocessor can be designed to do all the different tasks. A microcontroller can be integrated circuit which can be capable of being programmed to perform a specific task. Terms of microcontroller are host, target, and cross-compiler. Microwave oven. So coming towards what is microwave oven? Microwave oven is basically a device used to heat food using an electromagnetic waves. There are three types. There are micro mode, grill mode, and convection mode. We have used the start button to start the microwave. So micro mode. The mode is used to cook food in a traditional manner. The maximum power of it is 900. Grill mode. This mode is used to cook meat and bread. Users can set timer as per the cooking time of the food. Convection mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes up to 3 minutes to preheat the oven. After preheating is done, then user can set the time as per the requirements. The requirements of this project are MPLAB X IDE, XIDE bundle, PICSIMLab, PIC16F8, 77A, 16x4 CLC, Taxel switch, MKP timer 2. I'm Sushma and I'm going to explain about the PICSIMLab architecture. The basic architecture is shown in the figure, and we are mainly going to use CLCD, matrix keypad, buzzer, LEDs in this project. And the PICSIM 16F877A contains 40 pins and 8-bit controller. The next will be CLCD display. In this we are going to use 16x2, and in this we are in this RS register line implies 1 as data and 0 as instruction. Read and write mode will be equals to 0. Then we going to write mode. Next will be the tackle switch. Tackle switch is a switch whose operation is perceptible by touch. This switch is used to select the mode of operation and to enter the temperature of the operation. Switch. This switch will produce a bouncing effect as shown in the figure. You can see the figure, the bouncing effect of the switch. Next is the matrix keypad interface. It is nothing but a 12 touches of switch, and it contains to RT3 as the output to the microcontroller, and 4x3 is the keypad, and 4 is the rows and 3 are the columns connected to the PICSIM16F877A. Interrupt service routine is a software routine that hardware invokes into response to an interrupt. This interrupt helps the program to where if there is any problem in the program, so the interrupts help. The next will be the timer. Timer helps the micro oven if to cook the food, and we are using 4-bit timer to count the timing and to decrease it. Buzzer. A buzzer or a beeper is an audio signaling device. Typically uses of buzzer and beeper includes alarm devices, and this buzzer is mainly used for the helps the user for the process of cooking food. And these are the embedded programming. As in our internship, we used module.c, main.c and main.h and module.h in our program execution. Outcomes of the program.
Okay, I'm Tanmay and I'm going to show you the outcomes of the project. So far we have executed as shown as you can see the code, and we are using MPLAB X IDE 6.15 is my version of MPLAB X IDE, and I have created a microwave oven project which has the header files as clcd.h, main and matrix keypad, which also consists of a header file and a timers. And the timers that we are using in this is 4x4 matrix keypad, and it has the following source files also. So as you can see the code, and it has all the modes that are required for the microwave oven. I'm going to build it. Yes, the output is successful, so we can stimulate in the PICSIMLab. Okay, so I'm going to use the board of this PICSIMLab. I'm going to use it as PICGenios, so which has yes, as you can see, it is a PIC16F877A is the version of the microcontroller that we are using for this project. So I'm going to load this hex file that we have coded in the MPLAB X IDE from this documents, as you can see. That's how you have to do it. So we have to use the hex file for the code running. So you can see the powering on of the microwave oven in the before slide, right? So and once the oven is started, we have the following modes, which is micro mode, grill mode, convention, and the start or resume mode. So micro mode, we have seen earlier why we have to use micro mode, grill mode, and convention mode and start mode. So we're going to see the execution part in this output scene. See, I'm going to press the key 1 for the micro mode, and it has a power of 900 watts. So I'm going to set the timer as per my cooking requirements. Say 45 seconds and 2 minutes. Okay, let's enter. As you can see, the timer is started and the fan is running. Okay, if you want to stop it, or else if you want to go for the other mode, you can just stop it and go for the menu bar. Or else if you want to resume it, and again you have to press the micro mode and set the time. It's up to you whatever the time you want to set. It's upon the timer. Okay, if you want to stop it or pause it, press switch number 5, such that you can see the fan is stopped and the heater is stopped, right? Okay, if you want to give an indication to the user, you can just simply press RB3. See, if you want to continue it, press 4 and you can, yeah, this is how the user is informed through a buzzer. Okay, now let's go for the previous session. For that you just have to stop this. Okay, what if I wanted to go for the grill mode? I just simply have to select the option number 2 and then set the timer. Say let's 12 seconds and 1 minute. Yeah. Okay, see, the timer is going to be reduced initially and then the fan and the cooler starts cooking. Okay, now let's go for the other mode. I'm going to stop it and then I'm going for the convention mode. Yeah, what is convention mode? Where the heater is preheated such that the cook can be, it is preheated. So I'm going to set an initial time temperature, say 45 degrees Celsius, and then I'm going to enter it. So you can see, right, preheating time temperature. So this is how you get the output of a convention mode. And similarly, if you want to tell the user or else the owner of the you can do it with a beep. Okay, so this is the output of the project, and now let's go for the beep. Okay, see. So this is how we have seen the power on screen, and it has the following 4 modes: micro mode, grill mode, convention, and the start mode. So which is followed by 900 watts power. Grill mode, we have to set the temperature and then we have to go for the other mode. In case of convention mode, as the oven is being preheated, it is going to ask you the temperature, and it depends on the requirement, and then you go for the preheating. Once the preheating is done, you will be notified with a buzzer. We're going to send an alarm for the user. That's it. Now once it is done, the door status can be notified to the user. Okay, thank you. And at the end of the session, I wanted to say thank you for the Emertxe for letting us to know such a valuable information, and a word of thanks would be very much less for them. And thank you for this opportunity, and the outcomes from the project are very useful for us. And also the last few sessions from the workshops also made us understand what's the current situation for an electronic students in the outside world. And thank you very much for this opportunity. Thank you.